going to do to finish off this chapter, and Madison, remind me, I got to get you a few more notes that were not in the group I gave you because I did yours early because you were going to be away. I'm going to finish up with a couple of miscellaneous topics in this chapter, mostly review, one thing new. So hang in there here as we deal with today and then deal with tomorrow. All right, this one I'm just adding a little bit to the quadratic function. So 12.7 is quadratic functions, but before we get there, we better remember linear functions. Look, there's no way you are ready, quote unquote, to advance past Algebra 1 without being thoroughly familiar with y equals mc squared. Now, on every test since we've done slopes and y-intercepts, I've had questions on the front asking you the slope and asking you the y-intercept. I don't know if you've bothered to really look at your answers there. You should have. Which also reminds me, somebody remind me at the end of the period today to pass back your last test. I was holding it until everybody took it, and I think I still have it. So, but slopes and y-intercepts. So quick refresher. Now that we've done quadratics, how do you know if it's linear? Well, if you notice, our variables work to the first power. Don't do this in your notes, but notice the y is to the first power and the x is to the first power. That's how you know it's linear. Linears are to the first power. Now, that's a generality. There does come a situation where you can multiply the x times the y. It's a special situation. Other than that, that's how you can tell. Remember, it's a function if there's two different variables, Earth to daydreamers. If you have an x variable and a y variable, it's a function. If you have an r variable and an s variable, it's a function. If you have a t variable and a q variable, it's a function. If you had only one variable, it would be an equation. There's nothing to graph. It's a point. But with it two variables, now we have a whole infinite number of solutions. All right, and hopefully remember slope-intercept form. As you remember, the m is the slope, and the b is the y-intercept. Again, you don't need to put that in your notes. And therefore, then, if we had the example right here up top, y equals negative 3/2 x plus 2. If you remember, we're going to graph the y-intercept first. That's the plus 2, right? Up 2 on the y-axis. And then remember, from there, you're going to use your slope. Don't forget the top is the vertical change. So I have a negative 3. Negative says go down. How far? Down 3. And you can see I went down 3. The bottom tells you left or right. The bottom is positive. Positive is to the right, so I go right 2. I get my second point. I draw the line, and there we are, right? We should all be very familiar with graphing lines using slope-intercept form. It is quite important. So just by way of refresher, why don't you go ahead and graph that? Just worry about A right now. Graph 3y equals 5x minus 6. 3y equals 5x minus 6. If you're not sure what to do, you can look up for a reminder. Hopefully you're going to put this in a proper form first. Hopefully then you're going to graph your y-intercept first. From the y-intercept, you're going to use your slope. Going to plot your second point, and that's where your line is going to be. Right, and yours should look something like that as well. It should be right there, right? So you had to solve it for y. In this case, all you had to do is divide both sides by 3. Remember, you divide every term by 3. Sometimes you'll have to move an x as well. If it would have been in standard form, you would. Move the x's by adding their opposite to both sides. Move any multiplier of the y, as we know, by dividing by that value. Okay, so no big deal. What about a question like this, though? B, is 1218 a solution of 3y equals 5x minus 6? Well, our graph doesn't go that far, does it? So how would you answer that question? Now, this should be a very easy question to answer. if you understand. So let me give you a second to think. Again, that's the line graphed, but one, our graph doesn't go that far, and two, we don't need the graph to figure out the answer to the question. So somebody tell me, how would we figure out the answer to this question? Madison? Okay, correct, but you made it harder than you needed to. Instead of isolating anything, just right away sub in 12 for the x and 18 for the y. Don't worry about isolating anything. You're just making it more complicated than you need to. All you got to do is put in 12 for the x and 18 for the y and see if it's true. So the y is 18. Be careful. Make sure it goes in for the y. The x is a 12. 3 times 18, 36, 46, 54. 5 times 12 is 60 minus 6. Oh, look at that. 54 does equal 54, and therefore the answer would be yes. But don't bother isolating anything. You don't need to graph it. So it doesn't matter. Whatever form it's in, just sub in the x value for x, the y value for y, and see if the thing equals. Remember, the points are every xy value along the line. And those are the ones that give you an equal value. Any point off the line won't give you an equal value. Every point along the line is the equal value. So just sub in the x and y. Okay? Any questions on that? Right. Stuff we've done before, but I needed to refresh your memory as we move into quadratics. Let me just get rid of my shade here. All right, so we got to learn some things about quadratics. So it looks something like this. 1/2 quantity x minus 3, quantity squared minus 1. Way back when we said complete the square, I mentioned to you guys how completing the square helps us to put it in the graphing form. Well, graphing form, and I have general form there. I should probably put graphing form, not general form, is y equals a times the quantity x minus h quantity squared plus k. Have we dealt with h and k before? We have, right? See, math is nice. Things that you learned before apply in later situations. So even though this is quadratic, the hk is the value of our vertex. We've done that before. So that's good. However, there's a couple other things. For a quadratic, the shape is called a parabola. So that's something you should know. The shape of a quadratic function is a parabola. Andrew, I know you can catch. I want you guys to look at this. I'm going to throw it up in the air to you, so hopefully not hit the ceiling. I want you to look at the shape of this. Go ahead and throw it to me. Okay, and I'll do it right here to myself. You see that shape? I'm not making it be that shape just by throwing it up. It's that shape. That's a parabola. That's a parabola. The equation of this is quadratic, all right? That's a parabola. That's a perfect parabola. It's symmetrical. It's a parabola. Okay? They can go this way. That's called a min. Or they can go this way. And it's called a max. A parabola. All right? If an outfielder's going to throw the ball in the home plate, guess what? It's a parabola. If you shoot an arrow into the sky, guess what? It's a parabola. When Quantico is shooting their big guns, they're shooting parabolas. That's the way it is. Now, sometimes wind resistance and stuff will make things do, different things. Take a plane and fly, it's not going to be a parabola because of air resistance and wind resistance and such. But generally anything thrown is thrown in a parabolic shape. So the name is parabola. Positive A, it opens up. So it would look like this, and you can draw this in. It would open up like that. Negative A is like what I threw with a ball, and it opens down. It goes like that. And we call the vertex on the first one that opens up a minimum, a min value. It's the lowest value of the function. So it's a minimum, it's a min. And we call the vertex of the one that opens down a max. It's the maximum highest output value, or y value. It's got a max and a min. We'll deal a lot more with this in Algebra 2. I'm just introducing it to you now. But the graphing form allows us to understand all of this. All right, so let's see if we can apply this to what we have. First off, we got to figure out the vertex. So looking at our example function right up here, somebody tell me the coordinates of the vertex. What are the coordinates of the vertex? Sam, why don't you give that to me? 3, -1. How many agree with Sam? 3, -1. Again, we're getting the h value and the k value. Just like always, we read the h after a negative sign. So we have a vertex at 3, -1. Now, if you notice, I already had over here, vertex of hk of 3, -1. But again, hopefully you're reading it off of there, just like we've done for absolute value, just like we've done for other things, all right? We've done that before. All right, now, does this thing open up or does it open down? So, remember, positive A opens up, negative A opens down. So you got to look at the A value. Is that 1/2 positive or negative? So this thing's got to open up. See, it's heading toward all the positive values. It opens up. Now again, if you guys look at the ball, it's symmetrical, right? You see how it's symmetrical? Right? The sides match. So there's a line of symmetry, right? We're symmetrical. If we divide ourselves down, the center of our bodies, our left and right, are going to be symmetrical, right? So we're symmetrical, the parabola is symmetrical. And so we call it the line of symmetry. It's an imaginary line. Is it part of the graph? No, it helps you to graph it, but it's an imaginary line. It's not part of the solution. It's not, it doesn't solve the parabola, but it helps you to graph it. So you always put the line of symmetry right through the vertex. Okay, so I know my vertex is at 3, -1. I know my line of symmetry is right there, which would be actually an x value of 3. If I were to write the equation of the line of symmetry, it would be x = 3, a vertical line. By the way, this was on your test, infinite slope, the line of symmetry, no y-intercept on vertical lines. Okay. So anyhow, so how do we graph it from here in XY chart? XY chart. Now, let's apply what we learned with radicals. Remember when we were graphing radicals and we were doing mostly square roots and such? And again, we used HK there, didn't we? And remember how we came up with the next value to start with? Right? Do you remember how we did that? So, if you remember, we started in respect to the vertex. How would you want to start this? In respect to the vertex. That's what I would want to do. Where am I at right now? An x value of 3. So what's a good x value to use? 4. So I'm going to use 4. I'm going to go 1 away. I'm already at 3. I'm going to go 1 away. I'm going to go do 4. All right. So now we got to take the function, and where the x is in red, I'm going to write in that 4, right? So I have the quantity 4 minus 3, quantity squared minus 1, right? 1/2 times the quantity 4 minus 3, quantity squared minus 1. Hey, be careful, order of operations. 4 minus 3 is 1. Follow? Look at the equation. 1 squared is 1. 1 times 1/2 is 1/2. Positive 1/2 and a negative 1 is negative a half. So we get the point 4, negative 1/2. So go to your graph and plot the point 4, negative 1/2, and it would be right there. Right? 4, negative a half, right there. And here's the neat thing about the line of symmetry. Everybody look up here. Because I'm 1 to the right, I can, from that horizontal, go 1 to the left. I can get a second point. I get 2 for the price of 1. Everybody loves those, don't they? 2 for the price of 1. I get 2 points for the price of 1. Awesome. You can just stick it on the chair there, Mr. Mills. Is that Sarah's?
Yes.
Okay, yeah. That'd be great. Thank you, sir. So 2 for the price of 1. Awesome. All right, what X value are you going to try next?
5.
Let's go 5. And again, you can do the same thing. Where the X value is in the function, you're going to put in a 5. So look, you see the function right up above. Everything's the same except the red number. Changes, the X changes from a 4 to a 5. So you have it in front of you. So write 5 where the 4 is and everything else is the same. 5 where the 4 is, everything else is the same. All right, parentheses. 5 minus 3 is, come on, talk to me. 2 squared is, 4 times a half is, 4 times a half is. Boy, if you can't do that in your head, do something to get that in your head. 4 times a half is 2. 2 minus 1 is, all right, so plot the point 5, 1. And we get the point 5, 1. And for time's sake, that's all we'll do on this one. Now, draw your parabola. It's heading up, so put arrows as it heads up. It's heading up, put arrows as it heads up. Isn't that pretty? So by the way, we were 2 to the right. I did go 2 to the left, right? 2 for 1. Don't forget your 2 for 1 sale. 2 to the right, 2 to the left. 2 to the right, 2 to the left. Voila. This point here was 2 to the right. I went 2 to the left. All right? Kirsten. You guys right now, it's just going to depend on the parabola. Some of them go up more sharply, some go up less sharply. And you'll read in Algebra 2, you'll know when they do and when they don't. Right now, we're just getting introduced to it. All right, so let's do another one. So y equals the quantity x minus 1, quantity squared minus 5. Okay. So I got the general form, graphing form again there for you. Somebody tell me the vertex. Ethan?
1, negative 5.
Okay, and what was the first number?
1.
1, I agree. So 1, negative 5 is the vertex. And let's plot that point. So go on your graph, go to 1, negative 5, and plot that point. Does this thing open up or down? On 3, give me your answer. Up or down? 1, 2, 3. What's the value of A? What's the value of A? Say it if you know it. What's the value of A? 1. Is the 1 positive or negative? Positive. Positive goes up or down? Up. And again, look back if you need to. But again, it's right there. Positive A opens up. So this thing opens up. The way I usually do my line of symmetry, once I know that, then I just go up from my point. If it would have been open down, then I would put the line of symmetry down from my point. So I just do dashes for my line of symmetry. Okay, cool. Now we need a few more points to finish out our parabola. So what would be a good value to use first? Say it if you know it. 2, right? We're already at 1. Let's go 1 away. I'm going to go 2. What do? Again, I take the function, and where the x is, I put in the 2. Take the function. You have it right there. Why are you straining? You have the function on your paper in front of you. Take the function, where the x is, put in the value. You got to listen to what I'm saying. If you're just copying, you have no idea what you're doing. If you're just copying stuff off the board, you have no idea what you're doing. Nothing, no idea whatsoever. You got to listen and you do it. Take the function and where the x is, put in the 2. Okay, stay with me. Talk out loud. 2 minus 1 is? 1 squared is? 1 minus 5 is? All right, so that's our y value, right? Plot that point. 2, negative 4. 2 to the right, down 4, we got a point. And not only do we have that point, what else do we have? We've got its pair at 0, negative 4, right? 2 for 1 sale. Love those 2 for 1 sales. If I'm 1 to the right for that point, I'm 1 to the left for that one. All right. Next value, let's go to 3. All right, do your function with a 3 in for the x. Again, you're looking at your own function. Everything's the same except the red goes from 2 to 3. All right, talk to me. 3 minus 1 is? 2 squared is? 4 minus 5 is? Negative 1, right? So we're at the point 3, negative 1. So plot the point 3, negative 1. How far away is that from the line of symmetry? 2. Go the other way. 2. Right? Not to the coordinate 2, 2 spaces. Uno, dos. 2 spaces left. Right? This one is 2 right, go 2 left. You don't have to, just 2 left, right? On this one, it'd probably be nice to do one more point for time's sake. Let's just do it in our head. 4 minus 1 is? 3 squared is? 9 minus 5 is? 0.44. 1, 2, 3, 4. So plot the 0.44. Hey, how far away is that from your line of symmetry? So what do you do? Go the other way, 3, right? 1, 2, 3. Draw your parabola. Beautiful. We're spacious guys. Amber waves of grain. It's a work of art. Okay, I'm going to skip the next one. But guess what? This one would be opening down, right? This one opens down because it's got a negative a. And we will write the vertex, but we won't graph it for time's sake. So I want to get to the last one. So, Antonio, what's the vertex of this b function? 1, 7. How many agree with Antonio? The vertex is 1, 7. Okay? How many have? Who has something else? Connor, what do you have? How many agree with Connor? Negative 1, 7. Antonio, do you want to agree with Connor? Negative 1, 7. Yeah. Again, you forgot that it's got a plus, and I'll go through this one more time. I've been through this a lot. Remember, it would have been x minus a minus 1 for it to be an x plus 1. We've been through this a lot with radicals and with absolute value, and you can't forget that. You're going to make a mistake. Okay, so again, this one would open down, and this one would be a max, but for time's sake, I'm not going to do it. Let me deal with this last one. All right, there should be one more parentheses there if you'll put it there. All right, we don't know how to graph this thing. But there's a couple ways you can go. I could complete the square and put this in graphing form. Or I could be kind of tricky. And I could put this equal to 0. And I'm going to do that. Just set this equal to 0. Treat it like you're solving a quadratic. Do you agree you get x equals 0 for that? What would you get for the second parentheses? Ethan?
3.
Nope, not 3. What do you get for the second? Come on, we've done this before. What do we get for the second parentheses? All right, here's Look, surprising me. You have to think. Look, if all you're doing is trying to reproduce what I say, good luck with that. You will not go anywhere. You will not know what to do in any way, shape, or form. You have to understand what's going on. Okay, so let me move this thing if I can. So again, first lesson, set each little parentheses equal to 0 and solve the little equation. If x minus 3 equals 0, then x equals 3. There's the first value. So let me go back and ask the question again. What would be the value of the second equation? Raquel. Negative 1/2 is correct. Because again, you're going to take the 2x plus 1 and set it equal to 0. You're going to move the 1 and then you're going to move the 2 and you get negative 1/2. Okay, these are our two values. What I wanted to do on this last one is show you guys what these two values represent. I want to plot these points. What was my y value? 0. So guess what? I have the point 30 and I have the point negative 1/2 0. And guess what we call these points? We call them the zeros of the function. They're the x-intercepts, which, by the way, we've dealt with that concept already, way back when we did graphing. So I have an x-intercept or a 0 of 30 right there, that point. And guess what else I have? I have a 0 of when the x is 1/2. So I have that point, right? Negative 1/2. So I've got 3 and I've got negative 1/2. Now, let's think for a second. Why do we call them zeros? What's the y value? 0. Y is the output. So what's the output of these points? 0. And that's why we call them zeros. X-intercepts are called zeros. Because the output, the y value, is always 0. All right, cool. 2 points. Parabolas are, can you fill the next word in? All parabolas are, Nick, symmetrical. Can you figure out where the vertex is going to be? Where would symmetrical be? I should have given you an even one, but I didn't. Between positive 3 and a negative 1/2. Where would your vertex be? Can you figure that out? Can you figure it out? Are you going to ask a question or are you going to answer my question? Go ahead. If it was 0 and 3, it would be 1.5. You got to add in the quarter. 1. So you got to go the other way. You are 1 3/4 from negative 1/2. All right. I'll quit there. You guys got your homework on your paper, right? Hey, you're going to find that you're not doing much tonight.